Limit and its relation to differentiation. In this video, we will go through several types of questions related with limits and how to answer the question. Determine the following limits as x approaches 0 for this function. So to get the limit, we first substitute 0 into x. So we just substitute 0 into x. And then we will directly get the answer, which is -3/8. So let's move on to the next question. As x approaches 1 for this function. Okay, so let's say if we directly substitute 1 into x as we do as the previous question. So we will get 0/0, which cannot be the answer. Based on this, for fa equals to 0/0, we either factorize the function or rationalizing its numerator or denominator. Okay, so for this type of question, we will factorize the function. So for x squared plus x minus 2 become x plus 2 x minus 1 over 3x minus 3 become 3x minus 1. Then we need to simplify it. And become x plus 2 over 3, and then we can directly substitute 1 into x. So 1 plus 2 over 3, and the answer is 1. Limit for this function as x approaches 1. So let's say we directly substitute 1 into x, and we'll get 0/0, which cannot. So based on this, for fa equals to 0/0, either factorize function or rationalizing its numerator or denominator. So the best way to answer this type of question is by rationalizing its denominator. So x minus 1 over square root of x minus 1 multiply with its conjugate, which is square root of x plus 1. We multiply the numerator and denominator with its conjugate. So just multiply numerator with numerator, and the denominator and denominator. So we don't need to expand the numerator, but we must expand the denominator. Just write it back, the numerator, and we get x minus 1. So we can simplify it, and it become square root of x plus 1. So we can just directly substitute 1 into x, and the answer is 2. So let's directly substitute 3 into x, square root of 9 minus 3 over 3 minus 3 become 0 over 0. So cannot be the answer. Same as the previous question, we using rationalizing its numerator or denominator, but this question we will rationalizing its numerator. So we will multiply with its conjugate, which is square root of 6 plus x plus 3. Multiply its conjugate with numerator and denominator. Multiply the numerator and numerator, and denominator with denominator. And then we must expand the numerator, become 6 plus x minus 9. But we don't need to expand the denominator, so just write it back. Do the operation for numerator, we will get x minus 3. Again, just write it back, the denominator. To simplify it, we factorize the numerator, and it becomes negative 3 minus x. Then we can simplify and will become negative 1 over square root of 6 plus x plus 3. So then we can directly substitute 3 into x. And we will get negative 1 over 6. So next question will answer this type of question. Find dy over dx of each of the following by using the first principle for y equals to 4x minus 1. By using formula delta y equals to fx plus delta x minus fx. First of all, we must know that fx equals to 4x minus 1. So fx equals to y. So if fx equals to 4x minus 1, then fx plus delta x equals to 4x plus delta x minus 1 minus the fx for x minus 1. And don't forget the bracket. Then we expand, come 4x plus 4 delta x minus 1 minus 4x plus 1. And do the operation and we'll get 4 delta x. To get delta y over delta x, we then move the delta x to the left side. To find dy dx, we use formula dy over dx equals to limit of delta y over delta x as delta x approaches 0. Then we substitute the value of delta y over delta x with 4. Apply the limits property and we get 4. So the dy over dx equals to 4